Okay, today we are going to expand powers of binomials. That means we're going to have a binomial raised to a whole number power and expand it, which in the past it's been just raised to the second power, which means you write two of them and you FOIL it. Now we're doing higher powers, 3, 4, 5, 6, and we're going to go over a method to make it easier on you. First of all, let's just find the product. A plus 2b raised to the third power. That means I'm going to write a plus 2b 3 times. 1, 2, 3. I'm going to grab the last two of those and just FOIL it. First, outer, inner, last. And I'm not working through the first, outer, inner, last for you guys because we've done this a lot and you've gotten really good at it. So first, outer and inner, and last. Then I multiply it by this third one. I'm going to set up that table again because I think the table is pretty simple. Okay, what's in purple right there and what's in black? Okay, fill in the table, do your multiplication, and add your diagonals. 6, 12, 8. A squared, 6, 12, and 8. So not horribly difficult. Let's try another one. To the fourth power. So yeah, this isn't difficult math, but the more powers we go, the sort of more tedious the work is. So if I've got 4 of them, I'm going to FOIL these first two and FOIL these last two. So I have 2 polynomials. I'm going to set up that same table again and fill in each square of the table. Once I'm done with that, I add the diagonals because I have the same variable with the same exponent, collect like terms, and I have an answer. Pretty simple, right? Okay, let's go over something called Pascal's triangle. Okay, I'm going to talk about this for a second and give you a second to push pause and copy it down. Here we have all of our powers, just a plus b, very simple. To the 0, to the first, second, third, fourth, and fifth. If I expanded it, anything raised to the 0 power is 1, anything raised to the 0 power is 1, anything raised to the 0 power is 1. Okay, to the first power, we FOILed it. Okay, we FOILed it twice, or we FOILed the last 2 terms and multiplied it again. This is the example we just did, and then it just gets bigger and bigger and bigger. Pascal's triangle, these are just the coefficients, the numbers in front of the variables. 1, okay, 1 and 1, I have a 1 and a 1. 1, 2, 1, see, 1, 2, 1. 1, 3, 3, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. I'm obviously stating things that you guys can read in the last one. 5, 10, 10, 5, 1. 5, 10, 10, 5, and 1. And I'm going straight into an example. And the examples, everything's color-coded. You may have to pause and write some things down. But once you recognize the pattern, it's actually pretty easy to do. First example, we're doing to the power of 3. So that third row of the Pascal's triangle. And these are the coefficients, 1, 3, 3, and 1. Okay? This is your A, and that's your B. So I'm just going to point out the patterns to you, and hopefully as you work through one, it'll make sense. So the K and the -5, A and B. The A term, we start out with 3 because it's raised to the third power. 3, 2, 1, and 0. The B term, we start out with 0 and go up. 1, 2, and 3. That should be a 3. Put a 3 right there. Okay, these are the coefficients written in red. 1, 3, 3, and 1. 1, 3, 3, and 1. And that's really, that's the pattern in Pascal's triangle that we're going to work with. I do the math. K to the third, coefficients 1. 3 times -5, k to the second. 3 times -5 squared, this is 25 times 3. K to the first. K to the 0, anything raised to the 0 power is 1. And 5 to the 3rd, negative 125. So the pattern, you recognize the pattern, you can do it. A, B, n is 3. Those are your coefficients. Same thing here, A to the 3rd power, to the 2nd power, to the 1st power, to the 0 power. B to the 0 power, to the 1st power, to the 2nd power, to the 3rd power. Coefficients, 1, 3, 3, and 1. That's your pattern. And then just working through the math. Okay, to the 3rd power times negative 8. Sorry, negative 8 to the 0 power, which anything raised to the 0 power is 1. 3 times 6 squared times negative 8. So 6 squared times 3 times negative 8. 6 to the 1st power, negative 8 squared times 3. 6 to the 0 power, negative 8 to the 3rd power times 1. And that gives you your answer. We're going to do one higher order one, and hopefully the pattern now is clear to you and it'll all make sense. To the 5th power, so n equals 5, and these are your coefficients. Okay, I have A and B. A to the 5th power, 4th power, 3rd power, 2nd power, 1st power, 0 power. B, 0, 1, 2, 3, 4, 5. Coefficients, 10, 10, 5, and 1. Then you just have to do your math. Okay, there's no collecting like terms in this. X 5th, anything raised to the 0 power is 1. 5x to the 4th times negative 4, negative 20. 10, negative 4 squared is positive 160. 10, negative 4 to the 3rd power, negative 640, etc., etc. So I really think, especially for the higher order or the higher power binomials, that Pascal's triangle makes much better sense. Thanks a lot.